Welcome to the Maine Science Podcast. I'm Kate Dickerson. This episode is something a little different than our other ones. Rather than a conversation about a path to science, I spoke with Shawn Laatch and Nikita Saini about the recent total solar eclipse in Maine and the NASA Citizen Kate 2024 project they headed up for the Northeast region. I thought we already knew all we needed to know about the sun, but it turns out we are not there yet. A total solar eclipse is a great opportunity to actually fill in a lot of knowledge gaps, and that's what Citizen Kate 2024 was all about. I hope you enjoy this conversation as much as I did. Nikita and Shawn, welcome to the Maine Science Podcast. This is kind of a special post-eclipse science exploration conversation that we're going to have here. Shawn's been on the podcast before, so listeners can go back and listen to that great conversation. So Shawn, you can just give a super quick background of who you are, but Nikita, I would love to hear more from you about who you are, how you got in this eclipse game, and then we'll dive into actually more questions that I'm going to ask you about the science that you all did during the eclipse that I can't believe was only a week and a half ago. So Shawn, I'll pass it to you first.
All right. I'm Shawn Laatch, I'm the director of the Versant Astronomy Center in Jordan Planetarium here at the University of Maine. I've been in October of this year, or September, I'll be celebrating 40 years working in the planetarium field, and got started as a high school student and just sort of continued from there, and have been lucky enough to now see 6 total eclipses over my career. So yeah, it's been good. I think that's probably enough about me.
Hey, Nikita, hit us.
Yeah, my name is Nikita Saini, and I am a PhD student at University of Maine in the Physics and Astronomy department. Well, Shawn is the reason I was on this project, and he can tell a little bit how he made that decision. But yeah, he asked me if I want to do this, and it's been really cool, and we get to go to Australia. And I was like, sounds good. There's science, there's travel. Why not?
So I'm going to make you back up really quickly. I've already made Shawn answer this question. Tell me about why astronomy for you and why science, and then we will dive into the project that you mentioned.
So the reason I got into science, I always wanted to do something in science. My parents kind of pushed me into science too, but I liked it. I was always curious. But the thing about me getting into astronomy was seeing the Columbia space shuttle explode. It was on news all day, and one of the astronauts was Indian, same as me, and her hometown was 2 hours away from us, so same state. It was a huge deal in the state, so they showed her accomplishments for a week straight, so that kind of really inspired me to get into astronomy and see what I can do. But as I grew up and got into more science, I liked the astronomy side a little bit more than being on the astronaut side of things. But yeah, it's even if I was just taking science courses, I didn't get a chance to do astronomy courses by themselves. But all the bits and parts of astronomy that were in my physics courses, they always really excited me. So I'm actually really glad. I'm now in PhD working on a degree with astronomy concentration.
I find it really heartwarming that a tragedy helped inspire you to follow kind of in the footsteps of someone who was taken away from us.
I know. I sometimes think it's a little weird how that happened, but it's funny. I wanted to be a doctor before then. But I think it was just all the reports about her all day, that what she did, how she did it, and just highlighting her accomplishments, really. It's okay, maybe I can do that too.
That's really cool. Okay, Shawn, now I'm throwing it back at you. Nikita had alluded to this cool project that she's not sure how she got tagged for, and I know a little bit about it, but I welcome the opportunity for you to explain the project, the science that we are still learning about the sun. Nothing big here, just little pieces of it. I think one of the things that struck me most about all the background work that you both did to get to the point of this, it is the Citizen Science Project, right? Basically, is recognizing how little we actually do know about the sun and how it works, which is not obvious, I think, to even the most casual observer. This is not obvious that we don't know that much about the sun. So maybe you could give us a little background about what the project is and what that trip to Australia was, and then what the hopes were of what you were going to do when we had totality here in Maine.
Sure. So the Kate project, or Kate 2024 in particular, because there was a previous iteration in 2017, but the Kate 2024 project, which stands for Continental American Telescopic Eclipse, as I tell folks, NASA likes their acronyms. And this project was both NASA and NSF funded. It's led by the Southwest Research Institute. That's where the PI is based. And the project basically was to look at the corona of the sun in polarized light and to set up 35 stations or so between Texas and Maine to record totality and ideally to make a movie of the changes in the corona over the time of totality. So if all the stations were clear, we would have ended up with roughly 90 minutes of totality. That didn't happen, but we did get quite a few stations. So hopefully we'll still end up with a good length of time and looking at, again, how the corona works. So one of the things in terms of general sort of solar astronomy and solar physics is the sun, of course, we know is our local star, and the surface of the sun is about roughly 10,000 degrees Fahrenheit or so, but the corona itself can be up to 2 million degrees. And it's one of the things we've tried to understand is why that's so much hotter, because that's really the thin atmosphere of the sun, if you will, very thin and tenuous, but extremely hot. And it's one of the things we're really trying to understand. Eclipses over time have helped us determine the existence of helium in the 1860s, helped us prove Einstein's theory of relativity. And now, today, we're really trying to understand more about solar weather in general, how it affects us and our planets, what that's going to mean for astronauts in the future in terms of when we start sending astronauts to the moon and possibly beyond. But also just getting a sense of, we know our technosphere, basically all the satellites and things like that can be influenced by solar weather. I think November before last, we actually had some Starlinks that were knocked out by a solar flare. So again, we do know that solar weather is important for us. And a part of this project was really to understand a little bit about that connection of the inner corona to the middle corona and sort of the starting of space weather, if you will, affect us here on Earth. So that's a little bit of what we were trying to do with the project. And by being able to see it during an eclipse, that's really gives us a chance to view that corona. But by doing so over the path of totality, the idea again is to see it change over time. Because if you take an image, it's a static shot. It's kind of like if you take a picture of Jupiter, it's a static image. But that's not the way things are. They're constantly changing. And so this hopefully gives us an idea to see a portion of that change, which is not possible for us to do in any other way.
Now, just to make sure everybody who's listening understands, the corona is the outside ring when there's totality, right? Is that kind of the layman's person understanding of what the corona is?
Yeah, it's the atmosphere of the sun. It's only visible during a total solar eclipse. It's about 1/10,000th as bright as the surface of the sun. That's why, when the moon completely covers the disk of the sun, that's the only time we can see it here from Earth is during totality.
Okay, so being one of 35 on the path of the eclipse, trying to take this data is really interesting. Nikita, you had mentioned that you went to Australia, which, again, not obvious that there's a necessary trip to have to go halfway around the world in preparation for this. So maybe you both can tag team and explain to me why you went to Australia and how that prepared you for what you did a week and a half ago.
Yeah, I guess I can take that. Some people might have already heard that eclipses happen like every 12 to 18 months. So it's not like it's happening every month. You have to be at a specific spot to see it. So the Citizen Kate 2024 project is huge. There's 35 teams from Texas to Maine, and they all have to be coordinated on set because there's only about a maximum 4.5 minutes to make everything go well for those 4.5 minutes. It was really crucial that everything was set up correctly. And we had to do our dry runs to make sure that we can give the proper support to the teams and we know exactly what to expect. So the K team decided we should go to Australia last year and practice our equipment, see what exactly is needed, and just do some sort of like dry runs to like train the teams better. And because the eclipse was passing through Australia, that was also just a stroke of luck because it was passing through a very tiny bit of Australia. It was a long trip, but we did it. It was fun, but then again, it was a lot of work as well.
Yeah, part of the reason we were sent there, of course, Nikita and I were the Northeast regional leads for this project. So there were basically a Northeast, a Midwest, and a Southwest. And so they sent the coordinators and the trainers for each of those regions to Australia. And we also were testing between 3 different camera rigs to determine which camera we would want to use for the final project as well.
So how long was that eclipse in Australia?
62 seconds of totality. That was a very special one. It was actually what we call a hybrid eclipse, which meant at the tails of the path, it was actually annular. So it started as an annular, went to total, and then back to an annular. So that's something called a hybrid eclipse. But yeah, totality only lasted 62 seconds. So it was a long way. It was about 4 days of travel each direction for 62 seconds. Of course, you have the partial phases ahead of time. And we did lots of testing and getting our procedure down because, again, we had to train all the Northeast teams and all that. But yeah, it was a long way to travel for a short time in totality.
So during those 62 seconds, you also tested 3 different camera setups to see which one would work best so you could focus on one for your teams back here, right?
Correct. Yeah.
That's a lot of pressure for 62 seconds.
Well, we were there for a week and we practiced every day leading up to the eclipse. So, nice thing was it was summer in Australia and it was sunny every day. So, we were able to like practice a lot and then we were able to do that eclipse day. It went actually really smooth last year too. So, that was nice.
Okay, so you're the Northeast lead for the Kate project. And what did that mean for you when you came back? Let's see, you did that last.
Well, it was April 20th of 23 was when we had the eclipse in Australia.
So you had just about a year.
Right. Just under a year for things. Yeah.
So what was the team that you both led as the leads for the Northeast corridor? This is the citizen science part, if I have that correct, right?
Yeah. So we were team 33 and we ended up training 2 other teams in Maine. So there was one team that was sort of north of Holton and one that was north of Millinocket, because again, they had to be on the center line. Also a team in New Hampshire, one in Vermont, and then there were, I want to say, 4 teams in New York. Part of our job was to recruit state coordinators and then also to help them train their local teams. So we ended up doing the training for Maine here at our facility. And then for New Hampshire and Vermont, the state coordinator for that was Jackie Belfontaine, who is down at the Mount Washington Meteorological Observatory. I always have to let folks know that that's the case, that it's not an astronomy observatory, just because I get confused. But I went down and helped her also train teams there. So that was part of what we were doing in terms of that. So recruiting teams, training teams to be able to set up a telescope unit with a specialized camera to be able to track the sun and get, and collect the data.
And how hard was it to make that all happen?
Organizing it?
Well, organizing it, but also I would imagine that you recruited some folks who maybe have never actually even set up a telescope before, much less put together all these pieces to make it work, right?
Yeah, I think I can take that one. I was the trainer. I have a little experience teaching like introductory astronomy labs. So I kind of use that to like teach these people, especially the teams in Maine. That was the training session I led. And the teams actually are very like interested. That's why they got onto the project. So they were ready to learn. And it was not that actually hard. They followed it through. And we actually had a written procedure for them to just kind of follow every time they practice. So between that, I think our teams actually did pretty well. We only had one training session with them, and after that, they just had to like practice by themselves following the procedure. Actually, the core team wrote out, but there was a lot of iterations to that to like make it better or make it more easier to understand. But I think we got lucky with our teams.
Do you feel like you were on call with like a bat phone? If someone had any questions before the eclipse, they could give you a call?
We were supposed to be. I personally didn't have to do that for main teams. I had to do that for someone in New York. So I got calls from them. They were having trouble really figure out what was wrong. They were doing everything right, only to find out their latitude and longitude were flipped. And that was throwing everything off. And they were getting like really frustrated because it was happening, I guess, for weeks. But we were able to figure that out before eclipse. So that was good.
That's excellent. Okay. You both were at Jackman, right?
Correct.
Mm-hmm.
Which had a considerably longer totality than 62 seconds. So that's good. Did you have this setup plus other setups, or were you focused entirely on the Kate setup?
We tried to do a bit of both. So the Planetarium brought our entire grad team with us. So we had Andrew Teller, Brenda Jones, and Peter Manzella were with us that day. And so we brought other telescopes. We had a hydrogen alpha telescope, we had a sun spotter, and then there were a number of folks also. John Meter from Northern Stars Planetarium in Fairfield, Maine, he and his wife were there also with supporting telescopes. So we were able to help show people the sun in advance, like through a hydrogen alpha, which shows, of course, the prominences along the edge and shows the chromosphere of the sun, which was really nice because we knew there was going to be this really nice prominence that was going to be visible during totality because we saw it in advance through that hydrogen alpha scope. And there were some nice sunspots too that were really visible in the sun spotter. We did stargazing the night before because we wanted to make it a public event so that people could join us and have a chance to do some stargazing. So we did that the night before. We had about 200 people or so for the stargazing event. And then we had, of course, the day of, there were several thousand people in Jackman. The area where we were, there were definitely a few hundred folks directly around us with telescopes all over, but you could see like the parking lot across the way was full of people. The whole town was lined. They think that Jackman went from about 800 people to roughly 12,000 based on my recent discussions with the town manager there. So yeah, it was a little bit of a media circus as well. But yeah, we were trying to make sure that it really was visible for the public and people could observe with us and talk to us about what was happening.
Yeah, Shawn put a caution tape around our setup, and it was just so that like no one accidentally knocks down our setup. But because I had to be in there like babysitting the setup, and there was so many people, I felt like I was an exhibit that people were just looking at. It's like people were coming up to us and like talking to us. It just felt like a little museum exhibit.
I love the idea of you being an exhibit, just doing science work. So, Nikita, how did this experience of both working and explaining and having a really long totality, how was that all for you for what was a pretty great eclipse day? I'm still kind of blown away by how remarkable the whole thing was.
Yeah, it was satisfying in ways that people were curious about what's happening and they wanted to be a part of it. And it makes me happy when like people just want to learn more about science and experience all that stuff. It was so great. Weather was great. But it was like it was a lot of people around and they wanted to be involved. And they came up to me and kept asking what I was doing and how did that happen. And during the totality, I actually have a little recording. I just put down my phone and recording like everyone's reaction during totality. And you can like hear, oh my God, wow, and all of that amazing, all that stuff. It was great. This is something I didn't experience last year because we were just practicing and we were within like just by our living quarters and only like the resort staff was there to like join us. And it was 50 times more people this year that I got to experience this totality this year. It was great.
I got to experience it in Stacyville, and I was struck by how much joy there was in the anticipation before totality, but also the cheering and how excited during. And I'd heard of that, but I didn't really believe that that would really happen.
There was a family right next to us. After totality, the man said that he just came here because his wife wanted to see it. And he didn't really like care about it before, but he was glad that he came and he saw that. I guess it's like a lot of like life-changing experiences for people who saw it for the first time.
So, Shawn, how did this one compare to your other experiences?
You know, each one is special. It was nice to have a little bit longer totality this time because even in 2017, we only had a little over 2 minutes of totality. So this one having about 328 is what we had in Jackman was nice to have that more totality. But I think it was really special. One, because, you know, we live here in Maine, and I think it's special to see an eclipse from where you live. I had a chance to travel for, like I say, I've seen now 6, but this is the first one I was seeing from someplace that I lived. And that was special. And it was a longer one too. And I think that was really cool to have that. And we've been doing so much prep. And there were quite a few folks, and even since, who've come to, like last week, Friday night, the Planetarium show, and said, thank you for pushing really hard for us to go to the path of totality. I never thought it would have been as good as you said it was, but it really was. And it was more. And I'm like, yeah, it is one of those things you have to experience. That I think was really nice too, getting a little bit of seeing people very excited and very happy about the experience. And a number of folks traveled to Jackman to be with us too. And a few folks from the physics department were there. A couple of the professors came up, but also friends that just decided they were going to make their way up and joined us that day. And I think for a lot of them, it was their first totality and they were really blown away by it. That to me is the best part about Australia. The travel was a lot, but the best part was seeing Nikita's reaction to her first totality. And for me this time, I think it was just seeing a number of folks that I knew who this was their first totality and seeing that reaction, because it's something it's so hard to describe. All the words in the world and videos and pictures really just don't do it justice. Temperature, it's everything, the people, the crowds. And when you are observing with a crowd, I think there is this excitement. And it's a moment where, regardless of all the other divisions that might be in our crazy world currently, it seems to bring people together. And people are just so excited to be sharing in this natural phenomenon.
It's like one of those things like you can look at them, you don't have to say anything because you both experience the same thing.
That's so interesting. So my son is a graduate student at Iowa State and Ames. And so he looked at the calendar and he looked at the map and he was like, I can go to St. Louis for this, right? So he drove to the St. Louis area to catch totality there. And the part that was really cool for me was he's probably about 20 minutes ahead of us. So as we're slowly getting closer, we're getting texts from him saying, okay, that was cool. Like we had this little preview of what was coming almost momentarily. It was really, really interesting. And a lot of fun, right? It was kind of the same, what you just said, Nikita. Like we both had this really interesting experience that felt the same thousands of miles away because we knew he was in the path and we were in the path. So it was really cool. Circling back to the science just for a second, how will you guys know what you found? What kind of inroads were made? Will there be preliminary information that will be shared with you? Will there be a way we can track it and find out what more we've learned?
Yeah, well, we'll probably get a little bit today. We actually later today, we have a follow-up meeting from Kate, our first follow-up meeting since the eclipse to talk about things. And we do know that quite a few sites got data. And today we'll probably have an accurate count of that. And there's a plan for a preliminary paper or preliminary release of some information, probably the end of May is what the PI on the project is telling us in terms of a little bit of a release. But then I think then after that, really the full analysis, it'll take a little bit of time and probably later this fall is when my guess is late summer, early fall, it would be when we'd have more of an idea of what we learned and if we were able to make some of those connections about the inner corona to space weather and things of that nature.
I wanted to circle back really quickly. I realized I forgot to ask. So the groups that you trained, you said that they volunteered to be there and they wanted to be there. So besides perhaps a love of science and wanting to get into a totality, what was in it for them? I mean, I kind of know the answer, but I think people should hear it from you about this project is really cool on a lot of levels. But if you could explain it wasn't just training that these folks got.
Yeah, they each get to keep the setup from the project and hopefully be able to do some more astronomy with that. And that setup is quite nice. It involves an equatorially mounted refracting telescope with a variety of lenses, but then also the camera that was used to collect data and a laptop computer that went with it. So it's roughly, I think, about the last numbers I saw, about $8,000 worth of equipment that they'll get to keep. And of course, the hope is that that's housed at a location where it is, again, used to share with the general public. So it's not, it shouldn't end up in someone's basement or shed or something like that. One of the things that they were looking at was trying to connect it to schools or museums or science centers, places where it would be used and it would continue to share science with the general public.
Nikita, did this experience help you think about ways to do public science engagement and maybe building off the experience you had working with quote unquote regular people on getting citizen science? Is this something that you'd done before or that you would consider doing more of if you haven't?
Yeah, well, in some ways, working at the planetarium does kind of help me with that engage with the general public and communicate science in like easier words. So it kind of get people more interested in what's happening in space and astronomy and science in general. But yeah, one of my career goals is actually doing a lot of outreach. So the way like I was inspired as a little girl to go into science, do astronomy, I really want to do that for like other kids as well. So one of the things that's really excites me, even when I do like planetarium shows, is when little kids ask me like great questions, when they're curious. I'm like sometimes really impressed by how curious these kids are, and they sometimes ask like really advanced, complicated questions that I wouldn't expect a kid to be asking. But no, this project, I mean, didn't really got to work with like little kids, but there were high school kids. And this kind of gave me a little experience on how to do that on a bigger scale, I guess, and how to like engage. And there is like a whole Kate team that is just working with like public engagement and social media stuff and all of that, and how to kind of communicate the science. So there's like things I still need to learn, but it's really cool that how these projects, I know the project was like really trying to have people that didn't ever like use a telescope before or didn't know anything about astronomy. And I think that was the cool part about it. It's like they want to make this more accessible to people who wouldn't have that choice otherwise.
It'd be really interesting to see if a year from now, there's a group of alums of this project who are continuing doing outreach. And from what I've been able to tell with little chatter of different projects, this has certainly helped people get the astronomy bug. And it's not just about eclipse, but it's the whole exploration and science. So the second to last question, Nikita, does this have anything at all to do with your actual PhD research, or was this just an added extra science exploration that you did on top of all of your requirements for grad work?
It's very like loosely related to my PhD research. It's something more of an extracurricular project that I took over, but part of my PhD research does involve working with the UMaine Observatory. And I was training on how to use that, but then again, coming back to using a smaller setup and teaching other people how to use it does kind of help me understand a little bit more about how telescopes just generally work. And my work at the UMaine Observatory is just getting that to like set up to make it more accessible to the students on campus and maybe work with other colleges in Maine and other observatories in Maine that have similar setups. That is like Colby College, and there's an observatory in Greenville. But then again, I do exoplanets. So understanding about like stars is really important for understanding exoplanets. But I think it's really cool how one of the most popular methods for like finding exoplanets is kind of based on how eclipse happens. So you detect a planet if it passes in front of the star and some of the light dims from that star. Like eclipse happens, the sky goes dark. We don't see any light from that star. So that's the same concept that we use to find planets around other stars. So it's cool. And I guess one of the things I tried during the project talking to people was maybe talking a little bit about how other type of science can be started from one type of science. I mean, the idea of detecting planets came from somewhere, and we already know how eclipses happen. And just kind of putting that into like applications of science, basically.
That's really cool. All right, Shawn, I'm going to leave the last question for you. When you knew this next eclipse was coming in April in Maine, how much money would you have put on the table that Maine would have the best weather of anybody in the country? Because I know where my money would have gone.
Yeah, even in our programs ahead of time, I said, look, that if you want the best chance of seeing this, historically, Texas weather is slated to be much better. They're supposed to have an 80% chance of clear skies. We're only supposed to have 40%. I knew that the traffic would be kind of crazy, and I found a place for us to stay in Jackman and the team to stay. And I was like, we're going to be the evening of, we're not going to fight traffic, but we're either going to be commiserating or celebrating. And I said, more than likely, I think I sort of planned for the commiserating portion. But it was amazing, just the turn of events and weather that we had. I mean, we had PBS National contact us that Thursday saying, can we join you? Because it's going to be cloudy here in Texas. And so they came up and bedded with us in Jackman. And so we really won the weather lottery, as I tell folks. You know, I know that there was some guy who won the big Powerball around the same time. And I'm like, yeah, I'm happy with the weather lottery. I don't need that. I'd rather have this in terms of things. So we were very, very lucky. And in my mind, it was a great project. And part of the reason it was great is I got to work with Nikita and my grad students. One of the reasons I asked her to be part of this project is I felt that what she's doing in exoplanets, that made a connection compared to other graduate students who are doing things like on galaxies and star formation and relativity. So this, in my mind, was really perfect for her. And I thought that it would be hopefully a good opportunity for her. And I'm glad that she got some media coverage out of this too. So I think that's been something new and fun for her. And I've really enjoyed seeing her sort of blossom in that environment.
Well, I really appreciate the time that you guys have given me for this conversation. I do realize, as you put it, Shawn, it was all eclipse all the time for what felt like 6 months ahead of time. I'm also really appreciative of how much outreach you both did to really help convince people that totality was worth it. I mentioned that I got to experience it and kind of never any doubt that I would do it, but it really was great to hear some people, much like you've experienced, Shawn, saying, I'm really glad so many people talked about getting into totality because I'm not sure I would have done it otherwise. So I appreciate that. I appreciate the spotlight you've done on Maine with all of this. And I can't wait to see what the science is that it tells us from this. So thank you both.
Thank you.
Thank you.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. The Discover Maine theme was composed and performed by Nick Parker.